So here we are. Yesterday we were working on a problem. Today we'll continue working on that problem. I got stuck yesterday, so we'll come back to it. Man, I'm kind of running out of ideas a little bit. I think I have an idea of what to do, how to solve this. I don't know exactly, but we'll give it a shot. So let me go to the problem here, and forgive me, I forgot to open the web page before starting. Yeah, I don't know. I don't actually know the answer to this question that we're working on. We're gonna try to find out, but truthfully, I do not know. Oh, they changed the UI. Changed the UI. Daily challenges, huh? What does that say? Is that the daily challenge? Is that it? Oh. Maybe I should do that one. I'll do that one next if I have time. If I could solve this one, then I'll look to the next one. But I don't think I Oh, look at this. I like this. I like what they did. Oh, you know what? It might be because I canceled my subscription. Canceled my subscription. So hold on, let me see something here. Oh no, I have it. Yeah, I was like, I'll probably, what do you call that? I canceled my subscription. I will probably renew it at some point. However, there's a little bit of uncertainty in my life in the future, so I kind of want to reduce my expenses. And like, I have a lot of problems to go through before I'm going to be solving only the premium problems. But anyway, so the problem we're working on. If I can even solve it, now I can think about trying to solve other problems. Somewhere here, where'd it go? I have to sort these. We'll do 100. I've solved a pretty good number of these, so there it is. Can I win? Alright, that's the one. So here we are. But yeah, they changed the UI. I like that. I like that they changed the UI. I have a solution that'll work for small cases. It's a brute force solution. However, I'm looking for a solution that's more efficient than that. I don't have one. My thoughts were I can use Grundy values, they're called, from the Grundy Theorem, and it's going to be G of a set S and a total T is going to be equal to the MEX, which is the minimum excludant of the Grundy values calculated on each of the sets difference sum alpha and T minus alpha for all alpha in S. The problem with this, though, is that this is the number of subsets of S is going to be bounded by 2 raised to the 20th because the size of S is 20, and the power set is exponentiation, right? 2 raised to that power. The size of the power set is 2 raised to the size of the set that you're taking. The power set is the set of all subsets. So the set of all subsets is an exponentiation. The size of the set of all subsets is an exponentiation of the set, number of elements of the set. And then T is bounded by about 210. So we end up with an algorithm that's basically, this is also the running time of the brute force solution, which is way too slow, about 220 million. And the thing that's interesting about this is we do have, just thinking, hold on, if we square this, 100 million. I'm kind of surprised that this is so expensive, because I think that's something that's 100,000, 10 to the 5th. Yeah, that could be done in like 10 milliseconds. And so 220 puts you at 220 times 10 milliseconds times another 10, so 220 times 100 milliseconds is 22 seconds. Something like that. So but the point basically is, even though the total number of operations we need to solve this question for these relatively small numbers is probably under a minute, we need to do it in, I think, under like 2,000 milliseconds, so 2 seconds. So this is not fast enough. I don't think this approach will be fast enough either. This is actually slightly it's slightly slower than, whoops, hold on. I've been learning about truck driving. I think that's what I want to do. I don't think I want to be a software developer for the rest of my days. I think I might want to be a software developer either as a hobbyist, like somewhat amateur as a hobbyist, or I might want to build my own side business, maybe write software as like build my own kind of company. Maybe, I don't know. Like there are things that I would like to address that would require software development skills, but I think ultimately though it's just I've had a lot of frustration and I think I need a break. I want to try truck driving, see how that goes, find a wife, have children, and try to I don't know, man, serve God, I suppose. It's kind of hard for me sometimes when I think about it all. It's like, man, if I could only rewind the clock 10 years and still have all the things I've learned now. It's a funny thing about looking back in time. It's like, it doesn't work like that. Not only can you not do it, but also all the things that are true now and would not have been true if the things that happened didn't happen. So there's this kind of weird thing where it's like, you kind of needed those things to happen, whatever. You needed to spend that time to get to this point. What's up, Yuki? Welcome back. Hello. Welcome. What are these Chinese characters? Are you learning Chinese now? What's going on? I think that's Chinese. It doesn't look like it's Korean. Korean has more like loops, and they sort of look like it's more rounded. Korean characters a little more rounded. Could be Japanese, actually. I don't know if that's Japanese. I think that's Chinese. It looks Chinese. Welcome back. Hello. How are things? How are you? How have you been? It's been a few days. I think I didn't stream yesterday. Yeah, I'm getting my butt kicked by this problem, I have to say. Struggling. Yeah, I kind of want to. What I'm thinking I can do is try to print these Grundy values, and there might be some kind of a formula relating these values to each other that I could exploit. That's kind of what I'm looking to do, maybe to speed this up. Yeah. No, it just says American cheese. Yeah, it's Chinese Mandarin. Yeah, you know what? You know what? If you like Chinese, you know what's fun? There's a guy. I was just watching this video of a guy who um church attendance been light or non-existent. Ooh. Oh, ow. Oh, that would suck. Because a good number of preachers, they actually preach for a living. So if you don't have anyone attending your church, you're not making any money. Oh, that would suck. That would suck. What I wanted to show you is there's this guy. I can't say too much. What's his name? Chinese blown away. Let's see if we can find it. Also, forgive me as I'm scratching my face. I actually have been scratching my beard so much that I actually cut myself. It's bleeding. I now have like scabs under my beard because I've been scratching it so much. Let me see. I can't find it. You know what? The guy, he's not a Christian, the guy, so I don't want to spend too much time listening to him. Not that you only should listen to Christians, but I try to be kind of careful who I listen to, because you know, the things you consume kind of become part of you. But what I can't find him. There was this funny thing. I think you might appreciate if you have any interest in learning another language or any interest in other languages. Something that you might appreciate. I can't find it. It's like, hold on, it's gonna take me a moment. Look at this face, man. What is this? I can't find it actually. I don't want to look at my history, but maybe I will. Yeah, there we go. Something like this. Ah, this is the one. Yeah, here we go. Okay. Come to my house and eat Chinese food with my family. In retrospect, Lao Shu. It's a black guy that speaks like perfect Chinese. So here you go. He just walks up to some Chinese people and just starts talking to them in Mandarin. And they're like, what? Yeah, this is fun. Spanish. I watched this whole video. That was really cool. He started walking up, talking to these guys about in Chinese, and they were like, "Whoa!" And he speaks. This guy apparently, I think it's what he does professionally. He learns and teaches other languages. So meets a computer and starts speaking in binary. Yeah. So I want to recommend that video for you. Come to my house and eat Chinese food with my family. I think you'd appreciate it if you have any interest in other languages. It's a fun video watch. Is it the black guy that knows 500 languages? It might be him. Yeah, of course we only get dying people. When you say blown away in Chinese, their safety is non-existent. Yeah, it is the black guy that knows. You already know what I'm talking about. Oh, there you go. Wow, 500? Oh, dude. I'm over here spending 8 years trying to learn a few programming languages. I don't even know 500 programming languages. Forget speaking. Well, I don't know about literally. Oh, okay. Well, there are a lot of languages out there. If in India, there are so many different dialects of the different languages. Like a dialect is basically the same language, but it's so different that it's considered a different language. So like, I think he was just talking about Cantonese and Mandarin, right? Cantonese is, I think, a dialect of Chinese. I think. Could probably check. Let me see. Hold on, we'll find out right now. Language within the Chinese branch of the Sino-Tibetan languages, originating from the city of Guangzhou. Well, I don't know how to pronounce that. Guangzhou, Canton, surrounding areas. Traditional prestige variety of the Chinese dialect group. Yeah. Dialect, right? Chinese dialect. So, I didn't mean to do that. Didn't mean to click that. He knows 50, I think. Wow. Dude, that's so many languages. That's so many. It's like, that's astounding. I don't know how many programming languages do I know. I could probably put down a few. I don't think it's 50. It's like, it's up there though. It's definitely double digits now. But I wouldn't say I really know them, you know? Like I don't like really work with these different languages a lot. But I've learned quite a few over the years. But I don't know 50. Definitely don't know 50 programming languages. It's so many. It's so many. I maybe know of 50. The existence of 50. 50 languages. Whoa. What was I saying? So I don't know the solution to this problem, man. Like my best bet right now is just to start outputting Grundy values and see if I can find some pattern, but like it's such a far cry from, it seems so improbable that this would yield a solution. I want to see how many times we actually reach the same state. Let me see something here. I don't think we ever do, realistically. Boolean int long. Test. And we're going to say if, so key is going to be standard make tuple of the state. It's S player, S current target, and S current values. I'm going to say if test.count of key is greater than 0. Say check. Otherwise, we're going to take our map, the key, and set it to, it's actually, in this case we can make it a set, because we don't even care. We're just checking to see how many times these keys would come up. I think never. I think it's basically never. I have to leave it. Oh, there's thunder. I'm over here forgetting how to write to people in Swedish because I speak too much English. Yeah. Now you just gotta learn some Chinese. You know, spice it up. You gotta go. Okay, fair enough. I'll talk to you soon. It's good seeing you, Yuki. I appreciate it. Why do you have to go? Because there's thunder. Are those things unrelated to each other? But it was good chatting with you. Appreciate you saying hi. Inset. Probably insert is what we want. Yeah, never. Basically never. Basically never. I think this one times out. Let's TL these. Oh, wait, what? That just may have been my mistake. This should TLE, I think. Oh, it doesn't. Okay. Oh, look at that. Whoa. Oh, no kidding. Wow. Oh. Whoa. Huh. Really? That's really interesting. You're kidding. This revisited the same spot. This revisited something. Really? Now that's amazing. That's astounding. I didn't think that. I didn't think that this had any kind of overlap. Whoa. Wow. I'm astounded. Really? This has millions. Oh, well, not millions, but that, wait, 1, 2, 3, 4, 5, 6, yeah, millions of lines of repetition here. Whoa. Whoa. Maybe I should be memoizing this here. Huh. Whoa. Okay. You don't actually need to make it greater than 0, by the way. Wow. Wow. I am amazed. I'm astounded. So return true. We set memo of key equal to true. Return false. Memo of key equals false. Same thing up here or further down. Not check possibility to false and to true. And what does this look like? Compile error. Oh. Tuple is now mapped to a Boolean. 8 milliseconds. Wow. Oh, that's a lot faster. What? Without memoization, this was... I'm so confused. How is it possible? What is even happening? I don't get it. What? What is happening? I thought I memoized this the other day. It didn't work, and I was like, all right, well, whatever. What? Now is this super efficient? Am I just a big dummy? Am I crazy? Am I losing my marbles? What is going on? No, this doesn't make sense. Huh? What? 4 milliseconds. Alright. Up the ante here. 40 milliseconds. Okay, alright. It's a little more what I was expecting. Okay, 100 milliseconds. Okay. Still pretty... Still kicking, but still slow. Okay, 336 milliseconds. Alright. Let's try 120. But that's a significant speed up to memoize this. It's pretty interesting. Considerable speed up. 252 milliseconds for 120. Wow. Okay, let's try 130. Alright. Let's see it. Okay, 1,000 milliseconds. Okay. All right, we're getting up there. We're getting there. We're getting there. I don't think we'll make the next one, but we improved our running time considerably. We weren't able to get past 120 before, or 125. It was something like that. It was like 122, 120. Whoa, we get to 140. Whoa, we're getting way up there. Before we were only getting to, without memoization, we were only getting up to what was the number? Without memoization, we were only getting up to 120, 130, 140, 150. Sorry, I'm just thinking. We weren't able to get past 122. I think it was. We weren't able to do 125. 20 and 125 wasn't working. So this is actually really considerable improvement. But I don't know if we'll make it past 150. I don't think so. It's getting too much. Oh, we got almost 2 seconds. I think past 2 seconds it starts to fail. So let's do 160. Yeah, we got to get all the way up to 210. So I don't think we're gonna make it. Like each level is adding more time. No, wait, what? 1,000? No, what? Really? Is that? You're kidding? No way. No way this works. No, really? Really? I'm shocked. I can't even imagine. Really? The memoization makes it efficient enough to function. Dude, my mind is blown. My mind is blown. Really? Really? I can't believe it. I think we solved it. I was struggling so hard the other day to solve this. And I thought I solved it using memoization, but I didn't. I guess I didn't memorize it properly. Brother, this is it. We solved it. That's it. And you can actually use an unordered map. Wow. You can use an unordered map to wow, this is a medium problem. This is not a hard problem if you could just memorize this. I'm shocked though. I can't believe it. We memoized our basically our brute force approach, our depth first search with memoization. I don't know what the efficiency of this algorithm is. I have no idea. I couldn't even tell you what the running time complexity is. It's pretty slow though. Like I think it just makes it on these parameters, but it's pretty slow. As you can see, like I think it's still exponential, sort of some kind of exponential. I don't really know, but and that's amazing. But I want to say I'm shocked. I'm astounded. Like that's crazy. So it has nothing to do with the Grundy values, by the way. It had nothing to do with the Grundy values or the Grundy Theorem. I mean, we went and learned that anyway. But what we can do is, so this really was just some bit manipulation and memoization. What we can do is can actually use an unordered map in the hash function. So let me show you what that might look like. Yeah, this is kind of neat. So this might be faster. I don't think it'll be much faster though. Probably not. So there's a key, there's a hash, right? So we just have to specify the hash. Key, t, and hash equal to, right? So we'll try this. The way it's going to work is we're going to make an unordered map. And we just have to specify the hash function. So it's going to be the key is still going to be a tuple. The class T is going to be a Boolean, but the hash we're going to set here. And we're going to say memwise using a custom hash function. It's not a perfect hash function. So we're going to say class tuple hash or custom hash. Just call it custom hash. And what we want to use is this function. So we can hash. We can hash basically all of the different values together. You just need this operator, I think. So size t, what is? We don't really need a size t, do we? Could hash to an integer, I think. Yeah. 2 raised to the 32nd, or rather 31st minus 1 is only 1,000 million billion. Yeah, we don't need more. Yeah, we can go to an integer. We don't need more. So int operator, and all we need to do is define this operator, and I think, right? Yeah, const no accept, huh? Okay. And we're going to return. So you can hash the first name, hash the last name, and then take the XOR boost hash combine. I like that. Hash the first, hash the second, and then take this XOR, bit shift one of these, take an XOR. Pretty interesting. Can we do a hash for a long? Yeah, what do we get for the long? Oh, it is always size t. Okay, never mind. We always get a size t. So we're going to take const tuple reference t, and we're going to say it's bool int long. Can actually take the state. It doesn't have to be a tuple. It could actually just be the state itself as the key at this rate. In fact, yeah, you can do it this way if you want. And you can say state t s, call it s, const no accept, and we're going to say size standard size t. H1 is going to be s.player. It's going to be standard. We said this is in functional, right? Class key. Yeah, so we can do standard function. We can do standard function, include the functional, and then get a standard hash of bool of s.player, and we can do same thing, size t h2, standard hash of an int of s.current target, and do the same thing again. Long current vals, and then we can say return. We did. It doesn't really matter what you make. Would you make this function? Probably I should do the largest one. H3, H2 bit shifted once, and H1 bit shifted twice. We'll do it this way. I don't really know what this should look like ultimately, but yeah, the hash function itself really doesn't matter that much. It just needs to be reasonably good, sort of randomized, I guess. Let's try this. This compiles. Const bool. Can we do const bool? No matching conversion for functional style cast from const bool to standard hash const bool. Can I not hash a boolean? No, we got one. There it is. Template struct hash bool. Show me examples. Standard string. Oh, you gotta use these opening closing braces. I don't know what these are. I don't know why you need to do that. I guess this would construct the object, something like that. I don't know. Oh, and then now you just need custom hash. State to const unordered tuple. Oh, right, of course. This actually becomes the state then. This actually is no longer a struct. This is actually a class then. Okay, use a struct. The equal to is the issue that we have. We need a make these public, and then we need an equal to key equal to key. Left hand side equals right hand side. So we just need an equals operator, equals operator for this. I think. So I think we actually already are efficient enough. I think we already are efficient enough to solve the problem. I just want to see what it looks like to have to use an unordered map. I think the unordered map will be slightly faster. Although I could be wrong about that, but let's find out. Excuse me. Okay. What does this look like? Note an instantiation of member function unordered map state bool custom hash equal to state standard allocator standard pair const state bool count requested here. What's the error? An instantiation of member function hash table state pair const state bool allocator const state bool detail selected select list default ranged true false true count requested here. What is the problem? Static assert failed due to requirement is invocable. Const custom hash reference const state reference. Hash function must be invocable with an argument of key type. Oh. Is that the only issue? Is that the only issue? Const key reference. Yeah, it is. Is this not invocable? Parentheses were disambiguated as redundant. What previous definition is here? I'm so confused. The redefinition of temp with a different type. Custom hash versus state. Can we do something like this? Oh, it's a private member. That's why. Okay. That's why it's not invocable. Hey, there we go. Wow, it's so fast. Oh, that is very fast. Brother, is this real? What is going on? Cannot match. Yeah, okay, so we need the equals parameter. Need a comparator. So, I mean, this is astounding, right? This is, I'm shocked. I'm shocked. Yeah, look how fast that is. Look at how freaking fast that is. Excuse my language, but look how fast that is. I think we did it. I think we did it. I can't believe we did it, but I think we did it. Wow, no, really. No kidding. How about 100? How about that? I am amazed. Yeah, man. Looks like we got it. I don't know. I don't know how. I don't know why. I don't know nothing. I don't know nothing. All right. I don't know anything. I don't know up from down anymore. I don't know up from down anymore. I don't even know what's going on. I don't know nothing. I think we did it, man. How we did it? I could never tell. I could never tell. All right, let's go for it. I don't know. I don't know. But I think we got it. Is this... No way, man. Is this real? There's no way. This is crazy. This is crazy. Did we do it? Did we get it? No. I don't believe you. I don't believe you. I don't believe a word you are saying. I don't believe a word that you're saying. What happened? Where did we... Oh. Hold on. Where did I start writing this? 1, 2, 3, or no, 4, 20, 100, 20, 30, 1, 2, 3, 4, 5, 6, 7, 8, 8. Okay. 1, 2, 3, 5, 6, 7. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. All right. Happened to have put that in the end when I meant to put that in the beginning. I can't believe it. Did we really just solve this? There's no way. Yeah. I think we got it. Let's go for it. Hey, we did it. Hey, yes. Yes. What? Brother, that was ridiculous. We just went ahead and memoized a brute force solution. That was it. I mean, it wasn't the most naive thing, but like that was it. That's all we did. Like this was super simple what we did. I can't believe it. I can't even believe it. I can't believe it. I can't even believe it. No way, man. No way. By the way, the bits for the player we could fit in the current values. That doesn't need to be... That can actually be kind of... You could sort of save a little bit of time on that. And you also can... The current target, the bits for the current target, I think... there's 300, right? So... Yeah, so you can even do 2 to the 9th, right? I can't even believe it. I can't even believe it. Actually, you can do better than that. Because the targets are 20 are because the targets are at most 210. You can use 8 bits. You can use 8 bits for the target, 8 bits inside of the long, and then you can use 1 bit. So 9 extra bits, and the long is 64 bits. You only need 15 bits to represent 20 bits to represent the set. So that's 20 bits for the set, and then another 9 bits. Actually, excuse me, you could fit this into a single integer. Forget the what do you call that? Forget the, what was it saying? 'Cause, 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 'cause forget the forget all this other stuff of using a custom hash and using state class and all of that. You could fit the whole state in a single integer, the whole state that we're interested in, and so your unordered map can be just a single integer to a boolean. And also, by the way, there was a way to code this up so that we don't have this extra if else here. Excuse me. And you can so you can make the code even cleaner. You can make the code cleaner. You could hash this to a single integer, and all you'd have to do is extract the I guess the target value each time from the int that you're working with, the 31 bits. Yeah, you only need 29 bits. Also extract the you just extract the player value and the target value from each time from the state integer. You don't need that much memory, and then then the memoization is even more efficient. Wow, the whole problem is so much more efficient if you do it that way. But we're pretty good. I mean, we solved it. You know, we're okay. But yeah, I think if we want to do better than 36%, I think we would get 100% if we move the state into a single int and then 32-bit integer, and then we memoized on that. I think the whole thing will be extremely fast if we do it that way. It's pretty quick as it is, but it'll be really fast if we do it that way. This also doesn't need to be a long, I think, by the way. We could try that too. Just change that to an int. See if that makes things faster. Yeah, I think it will. Yeah, I think it still compiles, still runs, still works correctly. Not much faster. Actually, that was the slowest run we had, even though we only needed an int. Wonder why that is. I wasn't expecting that. Yeah, they're all kind of consistently not too quick. I think it's the memoization that we do. I think this part is the part that's costing a lot of time. This could be, yeah, if you make this faster, it'll make it way faster. I can't believe it, man. That's great. That's awesome. That's so cool. Wow. All right, we solved it. So we did it. I was struggling so much with this problem. I was struggling so much. I can't believe it. Yeah, wow. Here we go. By the way, I didn't explain the problem this time because it was sort of two parts already. But so we have in the 100 game, 2 players take turns adding to a running total, any integer from 1 to 10. Player who first causes the running total to reach or exceed 100 wins. What if we change the game so that players cannot reuse integers? For example, 2 players might take turns drawing from a common pool of numbers from 1 to 15 without replacement until they reach a total greater than or equal to 100. Given 2 integers, max choosable integer and desired total, return true if the player to move can force a win, otherwise return false. Assume both players play optimally. Yeah, I just simulated it. I mean, the constraints are small enough where you could just simulate this with a depth first search and a hash of the solutions. And yeah, you could do more to make this faster by shifting the data and the state into a single integer, and then just extracting from that integer the data you need in each step, and memoize that state. It's just memoize that integer, and then you don't need a custom hash. You can use just a regular hash, the built-in hash for the map, and just hash integer to boolean. Yeah. Yeah. Cool, man. It's really cool. Wow, we did it. I can't believe it. We got there. All right. I mean, I was like, man, I spent so much time on this. I didn't know what to do. But that's how you use, by the way, a custom hash for the unordered map. If you want to hash things that are, basically custom objects or classes beyond the ones that sort of already have a hash function built in for them. Like I said, the hash function itself doesn't really matter that much as long as it's reasonably efficient, like reasonable when when it comes to randomly generating collisions for the hash. It doesn't need to be perfect hash, but just needs to be efficient enough where it's feasible. Man, I'm like, we got it, we did it. Hey, hey, cool, sweet, awesome, wonderful. We got there. Not bad, man, not bad. That took a really long time, but yeah. I can't believe how easy that was, though. We had the right solution from the beginning. Like this, the right solution from the beginning was just brute force it with a relatively clever, maybe a little bit of bit manipulation, relatively clever. What do they call that? A relatively clever implementation that gives us an efficient and memorize it. But it's basically a depth first search through the kind of backtracking depth first search through the problem space. Yeah, that's it. What else can I say? Yeah, it looks like memoizing does save us a ton of computing, ton of time. Pretty amazed. It kind of prunes a lot of the branches, so to speak, in the tree. Yeah. Yeah, we're sort of navigating all the possibilities in the possibility tree, I guess. Amazing. This is so cool. I don't know, man. Basically we pretty much just memorize and simulate the game, and it's efficient enough to pass the test. I can't believe it. I'm pretty much shocked. Yeah. But yeah, like I said, we could use a lot less memory by using one integer instead of a boolean and two integers, and that would also allow us to not have to define our own state class and our own custom hash, and then we can use just an integer here. So that would make things a lot of these things a lot more efficient. The unordered map would also be a little bit defined a little bit differently, but we're not going to do all of that. That's not really necessary. So, sweet. All right. Well, we'll end there. I mean, maybe I'm like a little bit more proud of myself than I should be. It took us an hour to go get through that. I don't know, man. I don't know what to say. I guess I'm just grateful. So yeah, we did it, and let me go. I will talk to y'all soon. Have a good rest of your day. If you like this kind of stuff, don't forget to like and subscribe, I guess. Like, comment, subscribe, right? Those of you who want to. Yeah, man. I'm just, we did it. That's crazy, man. That's crazy. Yeah, it's definitely, you could solve this in like 5 minutes. I think so. The bit manipulation would be kind of challenging to do in 5 minutes, but the basic idea is there. Yeah, that's hey man, we got it. We did it. Okay. Alrighty, let me go. Take care.